Hello. Today we are talking about again rate of change and integration. So this is a mathematical methods question, also complex unfamiliar. Now, the reason for this is a complex unfamiliar means we will have come across a question we need to know using a different way to integrate a log function. So let's have a look at this question. So something to do with the ln, e-based log. This is a rate of growth of colony of pigeons on a remote island. It's given by this formula I'm highlighting in yellow. So d derivative p, population, with respect to time, is 15 times by ln. We know ln is a log, e-based log, t plus 1. P is population, time, t is a time. Now, time after the 1st of January 2000. So we start the measure this growth rate is after 2000. So initially there are 1,000 pigeons in the colony. So that means we will know if I interpret. So the question says initially means when t, sorry. So when t times by t equal to 0, population P0 is 1,000. So that's the initial population. So we need to find out when by 2020. So that means when 20 years later. So when t is 20, so what is the population? So this is a simple question, look like it, but the problem is how we can establish a relationship between population, which is what we call PT, against time. So we need a FT. So we don't know yet. So it's what? We have no idea. So that means we need to integrate. So because we know the rates of change, so we know dp dt is that. So obviously if I want to change the relationship between p and t, will be, so pt will be easily to integrate it. The ln t plus 1 with respect to time. So this is our goal, how we can solve that. This is that's why this question is on unseen question, because we haven't seen the formula of how do we integrate it. So the question is how to solve something like, well, sorry, not F. So integrated log, so ln, which is what? So we haven't done this formula before, haven't we? So let's introduce today how we solve this by using a new methods called, so this one I'm going to say integration. So we're going to use integration by parts. Now this maybe is come from the Math C program. So if you are Math C students, you should be familiar with integration by parts. So what is integration by parts? It's u, integrate u with respect to dv, v, function v, is u times by function u times by function v, and then minus integration of v and du. So that's the integration by parts. So I'm going to use this formula to solve the question of integrated log x. So I'm going to use that. So what we're going to do is we're going to start doing some change the variables. All right. So first of all, we need a u. So let's say if I call u, apologies. Okay. So first, let u equal to ln x. So this is we change to a new variable, a new function called u. So now we will see du. So derivative of u with respect to x will be 1 over x. So now we can change the dx. So if I cross multiply, so the reason I want to change dx is so we want to get rid of dx. So dx is x times by du. Now we still got one x to get rid of. So if I say because u is log x, so therefore x must be e to the power of u. So now we remove the x, the variable x, we change. So this become our u. So this is become our v. So in this formula, so e to the power u is become our v. So therefore, if I go to back to the so log x with respect to x become log x become u, and dx we change to e to the power of u times by du. So now we change from x in relation to x, change to, we got u and a v function. So because the v function, you can see e to the power of u, I'll just circle like that. So e to the power of u, so I can integrate it into that. So become v. So therefore, we're going to use that formula. U times by v, so u times by v, v is e to the power of u, minus integration v, e to the power of u, and du. So this is the simplified version. So now we will be able to change to u times by e to the power of u. So we know e to the power of u with respect to u will be same as e to the power of u and plus c. So this is our function. So therefore, we're going to continue to change u back to the log x. E to the power of u become e to the power of log x. So that's bracket. And minus e to the power of log x plus c. So we know e to the power of log x goes out, factorize. So there will be log x minus 1 plus c. And e to the power of log x, just x. So all right, so this is our log. So therefore we got formula come out. So therefore we got a log integration log x with respect to x will be x log x minus 1 plus c. So this is our formula. So I'm going to highlight it in yellow. I'm going to use it. So this is our formula for today. So now we're going to change that formula. Before the formula, we're going to use that formula to solve the p in relation to time. So therefore, we got pt. pt was 15 integration the log t plus 1 dt. So we can use the formula above. So it'll be 15 times by x. X is our t plus 1 bracket log t plus 1 minus 1 plus c. All right, so now keep going. So because we want to find out what c is, so this is c is still haven't, so what is c? So let's using the initial condition. So when t equal to 0, population was 100. So therefore we substitute. So therefore 100 equal to 15. So 0 plus 1 times by log 0 plus 1 minus 1 plus c. So therefore 100 equal to 15 times by log 1 minus 1 plus c. So we will see 100 equal to 15 times by, this is a 0. So 0 minus 1 is a negative 1 plus c. So the answer c will be 100 plus 15. So it'll be 115. So c is 115. So now we established the relationship between population of the pigeon and time. So would be, so 15 t plus 1 log t plus 1 minus 1 plus 115. So now we'll be able to find out what's the 20 years later. So therefore, so 20 years later, we substitute time equal to 20. So 15 times by 20 plus 1, 20 plus 1, substitution, 115. So the answer will be 15 times by 21 times by bracket log 21 minus 1 plus 115. So the answer will be approximately 759.02457. So therefore, approximately 759 pigeons. So the answer will be in 2020. There are in year 2020. There will be 759 pigeons in a colony. Okay, that's it. We finish this question by introduce a new way to integrate a log function. So this question is a complex, unfamiliar, because we need to use this integration by parts to solve that log, to integrate this log function to this. So this is the formula we're going to use. Thank you for watching. Hopefully you enjoyed it, and see you next time.